Hello everyone, welcome to today's session on RISC and CISC machines, which is a part of our course on microcontroller and industrial application. In this session, we will explore the key concepts behind RISC and CISC architecture, their characteristics, and how they differ. By end of this session, you'll have a clear understanding of this architecture and the application. Let's dive in. RISC stands for Reduced Instruction Set of Computer, while CISC stands for Complex Instruction Set Computer. As this name suggests, these instructions differ primarily in the size and complexity of the instruction set. RISC processors focus on simplicity, offering a smaller set of instructions with fewer addressing modes. On the other hand, CISC processors are designed to perform complex tasks with a larger set of instructions and multiple addressing modes. Let's develop deeper into each architecture to understand their goals and futures. The goals of RISC architecture is to simply the hardware by employing a limited set of basic instructions. Each instructions typically corresponds to a simple operations like loading, storing, or evaluating data. For instance, in RISC, a load command fetches the data from memory, while store command writes data back to the memory. This simplicity makes the RISC processor efficient and fast. Let's explain the main characteristics of RISC. Simpler instruction set to easier decoding and faster execution. It has more general purpose register, allowing for better data handling. Each instruction executes in a single clock cycle, which ensures the consistency. Instructions are uniform size, typically a single word. Pipelining is easier to implement in RISC, improving the performance. It supports fewer data types and has a simpler addressing modes. These features make a RISC processor suitable for applications that prioritize speed and power efficiency. Now let's move to the CISC architecture. Unlike RISC, CISC aims to minimize the number of instructions required to perform a task. Each instruction is more complex and can handle multiple operations like evaluating, loading, and storing data on the go. For example, multiplication commands might fetch data, perform the calculation, and store the result in a single instruction. This complexity, however, comes at the cost of increased instruction decoding time. Uh, Here are the key characteristics of CISC. Instructions are complex and require more decoding effort. Each instruction may take multiple clock cycles to execute. Instructions are larger, often spanning more than one word. Fewer general purpose registers are used since operations occur primarily in memory. Supports a wide range of data types and complex addressing modes. CISC design philosophy is idle task requiring fewer program instruction. Even it means taking more clock cycles per instruction. Let's compare RISC and CISC side by side. RISC reduces cycles per instruction, which leads to faster execution, but this comes at the cost of more instruction per program. CISC minimizes the number of instructions per program by combining operations, but the trade-off is more cycles per instruction. Both architecture aim to enhance the CPU performance, but take different approaches to achieve their goals. The choice between the RISC and CISC depends on the application requirements. Here is a practical example of how CISC and RISC differ in performing a simple task like adding two 8-bit numbers. In CISC, use a single instruction such as add to complete the operation in one step, but in RISC, the same task could be broken down into three steps: load the data into the register, perform the addition, and then store the result. This example illustrates how RISC requires more instruction, but each is simpler and faster to execute, whereas CISC uses fewer but more complex instructions. To summarize, we have explored the core concepts of RISC and CISC architectures, their characteristics, and how they approach CPU performance differently. We also looked at a practical example to understand these differences better. Understanding RISC and CISC is a fundamental of designing and programming microcontrollers effectively. In next session, we'll focus on how these architectures are applied in real-world processor. Thank you for your attention, and feel free to reach out me with any kind of questions. Thank you.